this episode, we focus on a part of AI security that has a foot in two worlds at once. It protects your systems from attackers, and it protects your budget from surprises. Rate limits and quotas are controls that restrict how often a service can be used and how much it can be used, and for AI systems that usually means limits on requests, limits on tokens, and limits on expensive operations like long context windows or tool calls. Beginners sometimes think rate limiting is only about stopping a denial of service attack, but in AI deployments it is also about preventing quiet abuse that drains resources and creates operational instability. The reason this topic belongs in a security certification is that availability is a security objective, and cost is an availability factor in AI. If your AI endpoint becomes too expensive to run, or if it becomes so overloaded that legitimate users cannot access it, you have an incident even if no data was stolen. Setting limits is how you keep the system usable, predictable, and resilient under both normal usage spikes and intentional abuse. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A rate limit is a rule like no more than a certain number of requests per minute from a user, an IP address, or an application client. A quota is usually a longer-term cap, like a certain number of requests per day, or a certain number of tokens per month, or a maximum cost budget per account. The difference matters because rate limits handle bursts while quotas handle sustained consumption. In an AI system, both are necessary because abuse can look like a sudden flood or like a slow drip. A sudden flood might be an attacker hammering the endpoint with requests to knock it over. A slow drip might be an automated script quietly generating content all day to extract value or to probe guardrails. Rate limits can stop the flood, but quotas can stop the drip. Beginners often assume that if authentication exists, abuse is unlikely, but compromised accounts and malicious insiders exist, and even well-intended users can accidentally trigger high usage with repeated retries. Limits are a safety net that assumes humans and systems will sometimes behave badly. Tokens are the basic unit of consumption in many LLM services, and token caps are one of the most direct cost controls you can set. A token roughly represents a chunk of text, and both input and output tokens contribute to cost and compute load. If you allow extremely long prompts and extremely long responses, you invite two problems at once: higher costs and more opportunities for unsafe content to slip through. Long outputs are harder to review and easier to hide harmful material in. Long inputs can include more malicious instructions and more sensitive data, increasing the attack surface. Token caps reduce these risks by limiting the maximum size of what the model processes and what it can generate in a single call. That might sound restrictive, but in practice it encourages better prompt design and forces users to be clearer. For secure deployments, token caps are also a way to make behavior more predictable because the model is less likely to wander when the output space is constrained. Cost controls are a broader idea than token caps because costs can come from many sources in an AI system. Retrieval can add cost by pulling documents and increasing context size. Tool calls can add cost by triggering external services, database queries, or workflow actions. High-capability models can cost more per token than smaller ones, which means the same usage pattern can have very different budgets depending on model choice. Cost controls, therefore, include choosing the right model for the task, limiting expensive features, and setting budgets at different levels, such as per user, per team, and per application. A key beginner insight is that cost is an attack surface, because attackers can weaponize expensive operations even when they cannot steal data. They can cause financial harm or force your organization to shut down the feature. When you treat cost as part of availability, rate limits and quotas become core security controls, not just financial housekeeping. Abuse prevention is where rate limits become clearly security-focused, because many abusive behaviors have recognizable usage patterns. For example, extraction attempts often involve systematic querying, where a user or script submits many prompts designed to map model behavior. Prompt injection probing often involves repeated rephrasing, where the user tries many variations to find one that bypasses refusals. Denial of service attempts often involve oversized prompts or rapid request bursts. Rate limiting helps by slowing these patterns down, which raises attacker cost and gives defenders time to detect and respond. Quotas help by cutting off the total volume an attacker can consume, even if they spread the requests out. Another benefit is that limits reduce collateral damage. If one account goes rogue, a quota can prevent it from consuming all resources and affecting other users. The overall idea is that you are turning unlimited access into managed access, which makes the system less attractive to abuse. Setting limits well requires you to consider who the limiter is enforcing against and what identity you trust. You can rate limit by IP address, but IP addresses can be shared or rotated, and they can affect legitimate users behind a shared network. You can rate limit by user account, but accounts can be compromised, and some users may legitimately need higher throughput. You can rate limit by application key, which helps protect a shared backend service, but if the key leaks, the attacker inherits that capacity. In practice, secure systems often use multiple layers, such as limiting by IP for anonymous traffic, limiting by user for authenticated usage, and limiting by client key for service-to-service calls. Layered limiting reduces reliance on any one identity signal. For beginners, the key is that limits should align with your trust boundaries. If you cannot trust an identity signal, do not make it the only throttle on the system. Quotas and rate limits also need to be tuned to the use case, because limits that are too low will break normal work and drive users toward unsafe workarounds. If a support agent needs to summarize many tickets quickly, a tight limit might cause frustration and encourage copying data into unapproved tools. If a developer is testing a feature in a controlled environment, they might need higher short-term throughput. A mature approach is to set default limits that protect the system and then offer controlled ways to raise limits for trusted roles, such as through an approval process or a higher-tier access policy. This is a security pattern you see elsewhere, like privileged access management, applied to AI consumption. The goal is not to punish usage, but to keep usage predictable and auditable. When users understand the limits and why they exist, they are more likely to plan around them rather than fight them. Token caps also interact with safety in ways beginners might not expect. Shorter outputs can reduce the chance of harmful content, but they can also increase the chance of missing nuance, which can lead to mistakes. That means token caps should be paired with good prompt design and good output constraints. For example, if you want concise answers, you might also require that the output includes a clear statement of uncertainty when facts are not supported by input. In retrieval systems, you might cap how much retrieved content is included to reduce leakage risk, but you need to ensure the model still has enough context to answer correctly. The best approach is to cap aggressively where the task is simple, and to allow more tokens where the task is complex and where oversight exists. Limits are not only a technical setting, they are part of your overall risk management approach. You adjust them based on the sensitivity of data and the potential impact of errors. Rate limiting is also a detection tool because it creates signals when users hit thresholds. If an account hits rate limits repeatedly, that can indicate automation, abuse, or a broken client repeatedly retrying. If many accounts hit limits at once, that can indicate a coordinated attack or a sudden spike in popularity that might stress the system. The way you respond matters. Sometimes you block, sometimes you slow down, and sometimes you require additional verification, like stronger authentication. The important part is that your system logs these events and that operators can see patterns. For AI systems, it is also useful to track not only request counts but token usage, because an attacker might send fewer requests but very large ones. Similarly, tool calls can be tracked because they may be the most expensive or risky operations. Monitoring consumption is therefore part of abuse prevention because it helps you differentiate normal use from suspicious use. Finally, limits need to be integrated with your maintenance and incident response plans because you will sometimes adjust them under pressure. During an incident, you might temporarily tighten limits to stabilize the system, or you might disable a costly feature like large context windows. During a new feature rollout, you might set conservative quotas until you understand real usage. During a vendor outage or capacity reduction, you might apply stricter rate limits to preserve service for critical users. This is why disciplined configuration and clear ownership matter. If nobody knows who can change limits, changes become chaotic, and chaotic changes can cause outages or unfair blocking. A secure program treats limits as security controls with change management, testing, and rollback. When you can set rate limits and quotas thoughtfully, you protect availability, protect budgets, and make abuse more detectable and less profitable. That is why these controls belong in a serious AI security toolkit, and why understanding token caps and cost controls is not optional for anyone tasked with operating AI systems safely.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.